Hello everyone, welcome to our capstone design project presentation. I'm Jenish.
I'm Nidal.
I'm Tahiat.
I'm Shammy.
The goal of this presentation is to introduce our project, demonstrate a working prototype, discuss about the successes and failures we encountered, and explore future avenues. We have developed this project for the North Alberta Radio Club, aka NARC. We'd like to acknowledge Dr. Stephen Knudsen and Mitch from NARC for giving us support and encouragement throughout the project.
The objective of the project is to create an open source modem that can send emails over the high frequency range. Imagine you are lost somewhere in the wilderness of northern Alberta. The only thing you have is your laptop and your HF radio. With no internet around you, you cannot contact anyone. However, with the help of OpenHFed, one would be able to reach out for help by emailing someone about the situation. How it works? Well, you would boot up OpenHFed email client and enter your credentials and email content and let the radio do its job of transmitting this data to the OpenHFED server, which sends the email to the recipient as shown in figure 2.
In the first demo, we will try to send string messages from a publisher to a subscriber. This will demonstrate the ability to send data from a Python program to another Python program via the GNU Radio communication stack. So let's start by opening up the GNU Radio companion. So as you can see in the GNU Radio companion, there's various modules corresponding to the transmitter side of the modem and the receiver side of the modem. Currently, the transmitter and the receiver are connected via software, and in order to obtain the inputs, we are using TCP source and sync to allow the publisher and the subscriber programs to input data and get data. So let's actually start by executing the flow graph. This will create a channel between the transmitter and the receiver. Now we can start our publisher program and our subscriber program. So let's input a hello world string. So as you can see on the receiver side, we receive the correct string. We also have the length, which is correct, and on our GNU Radio companion debug, we can see that each of the bytes were sent individually in the form of ASCII characters. So this demonstrates sending string messages from publisher to subscriber via the GNU Radio communication stack. So for the second demo, we'll expand the publisher and subscriber example from demo 1 to a client and server interface, where the client will try to send emails to a server via the GNU Radio communication stack. So let's start off by starting the GNU Radio companion, in which we will execute the flow graph from demo 1. This will create a channel between the client and server. Now we'll execute the client program and the server program. So for this demo, we have created a test example, test email account from which we'll send emails. So let's write the credentials for the email account. We'll send this to my personal account. We can have a test subject, and we can write any sort of body content that we want. So hello world, today is April 12th. So as you can see, the message was delivered to the server, and shortly we will get this notification that the email was sent successfully. So let's see if the email was, if I had received the email on my account. So yes, we can see that the email was sent just minutes ago, and we have the correct content and the correct subject. So yes, so in this demo, we have demonstrated the ability to send emails from a client to a server via the GNU Radio communication stack.
The approach was to divide the project into two teams.
The physical and protocol layer teams. In the physical layer, we constructed a modem using a software-defined radio, which allowed digital data to be sent over a radio frequency medium. For the protocol layer, we developed an application to transmit and receive emails between client and server using the SMTP protocol. In the physical layer, we managed to create a functional transceiver model that was to communicate between a client and a server. The transceiver modulates and demodulates signals using the Gaussian frequency shift keying scheme, aka GFSK. We also developed a packet communication inside a custom MAC layer to control the flow of data between the transmitter and receiver. Using TCP ports, we connected the GNU radio flow graph with client and server Python program. As for us, the concepts in communication systems and signal processing were new. Thus, we were not able to fulfill all requirements set out in the preliminary design for the physical layer. Particularly, our walking skeleton for the physical layer included sending and receiving bytes over RF medium. Unfortunately, we were not able to demonstrate this requirement. Additionally, the forward error correction and clock frequency synchronization components were not implemented as the preceding tasks were not completed.
As for the protocol layer, we managed to establish a client-server connection utilizing SMTP, which is the standard way of exchanging data between an email client and a mail server using various commands such as hello, receive. To achieve this connection, we use Outlook SMTP server for the NARC server side, as this is compatible with other email clients such as Gmail, Yahoo, and is also free to use.
Presently, the email credentials and body are sent without encryption through the radio waves, making it vulnerable to outsiders. Any middleman could intercept these radio waves and read the underlying data. We could encrypt the credentials using a symmetric key encryption, but sharing the keys would need an independent method. We decided overall to not include encryption in our prototype. Users are also restricted to the use of Outlook server as their mail servers, as different servers require different configurations that we did not look into.
Here are a few future requirements and features for the physical layer. To improve the bit rate of our modem, we could implement a multi-tone modulation technique like OFDM. We would also want to expand the MAC layer to include an automatic repeat request protocol. And to improve the portability, we would want to implement the modem on a hardware target like a Raspberry Pi.
With the protocol layer, firstly, encryption can be introduced by using symmetric key that is shared between two parties independent of the system for email data encryption. Further, our system can be improved by designing and implementing a user-friendly UI to enhance usability.